Hey everyone, welcome back to Cloud One Software. I am Professor Kenneth Orameli, PhD Computer Science. Today, we're diving deep into the world of software processes, a comprehensive guide that takes you from initial concept to final deployment. Whether you're a computer science student, entry-level programmer, or an experienced developer looking to formalize your knowledge, you're in the right place. Let's get started. At its core, a software process is a structured set of activities needed to develop a software system. Think of it as your master blueprint for an idea to a finished product. Every software process involves 4 key activities: 1 design, 2 implementation, 3 validation, and 4 evolution. Specification, also known as requirements engineering, involves defining functionality, identifying constraints, documenting user requirements, and setting acceptance criteria. Design and implementation involve architecting the system, crafting technical specifications, writing and organizing code, and setting up development environments. Validation includes testing individual components, integration testing, system-level testing, and ensuring user requirements are met. Evolution is about managing change requests, adding new features, fixing bugs, and adapting to new requirements. Let's now take a closer look at some popular software process models, starting with the classic waterfall model. The waterfall model is often considered the grandfather of software processes. Here's a quick breakdown of its phases. Requirements analysis, which usually takes 2 to 3 months, involves gathering stakeholder input, documenting requirements, defining system boundaries, and establishing success criteria. System design, taking about 3 to 4 months, involves creating architecture, designing databases, defining interfaces, and planning security measures. Implementation, which can take 4 to 6 months, involves writing code, documenting the process, setting up development environments, and unit testing. Testing, usually taking 2 to 3 months, involves integration testing, system testing, user acceptance testing, and performance testing. Finally, maintenance involves bug fixes, updates, and optimizations, and security patches. Pro tip: use the waterfall model when your requirements are well understood, technology is stable, and the project scope is clearly defined. Next up is incremental development, a flexible approach that breaks the project into manageable chunks. Here's how it works. Initial planning, identify core requirements, plan the architecture, define a release strategy and priorities. Increment cycles, which typically last 2 to 4 weeks each. Plan the increment, design, develop, test, and validate. Collect user feedback, integration, merge new features, conduct system-wide testing, optimize performance, and update documentation. Real-world example. Imagine building an e-commerce platform. Increment 1, basic product browsing. Increment 2, user accounts. Increment 3, shopping cart. Increment 4, payment processing. Increment 5, order management. Reuse-oriented engineering leverages existing components to accelerate development. The process typically involves component analysis, which usually takes 2 to 3 weeks. Conduct market research, evaluate available components, perform cost-benefit and compatibility assessments, requirements, modification, also taking about 2 to 3 weeks. Adapt specifications, negotiate changes, update documentation with stakeholder approval, system design with reuse spanning 4 to 6 weeks. Plan architecture for component integration, design interfaces and plan performance, development and integration, lasting 3 to 4 months. Customize and integrate components. Test and validate the system. Optimize performance. RUPI blends the best elements of various models. Its phases are inception phase, which takes around 2 to 4 weeks. Develop the business case, identify stakeholders, conduct initial risk assessments, define project scope, elaboration phase lasting 2 to 3 months. Deep dive into requirements, design the architecture plan risk mitigation, develop a detailed project plan, construction phase, which can take 6 to 8 months. Engage in iterative development. Regularly test and document, integrate user feedback. Transition phase, typically 1 to 2 months. Deploy the system. Train users, fine-tune performance, transition to the maintenance team. Modern agile practices have transformed software development by incorporating continuous integration and deployment. With automated testing, regular deployments, and immediate feedback loops, teams can maintain high quality and adaptability. Plus, DevOps practices like infrastructure as code and automated pipelines further streamline development and monitoring. When selecting a process, consider factors such as project size and complexity, team experience and size, time constraints, budget limitations, industry requirements, and client preferences. To ensure success, follow these best practices. Clear communication with regular team meetings, standardized documentation, and progress tracking with stakeholder updates. Quality control through robust code review processes, comprehensive testing strategies, and performance and security monitoring. And finally, risk management with frequent risk assessments, effective mitigation strategies, and contingency planning with change management. Remember, software processes are flexible frameworks, not rigid rules. The key is to understand your project's unique needs, choose the right methodologies, adapt as needed, and always focus on delivering value. Thanks for joining us on this detailed exploration of software processes. If you found this video helpful, please give it a thumbs up and subscribe for more in-depth content on software development. And don't miss our next video, a deep dive into agile methodologies. See you next time.